Welcome to SS Mathematics classes once again. In my last lecture, I discussed on integration by parts where I detailed about the formula integration UV. I'm writing once again integration UV dx, where u is the first function, v is the second function, equals to u integration v dx minus integration whole du dx into integration v dx whole dx. This is the formula what I discussed in my lecture 7. And I also told about some formulas, the well-known formulas. Usually all the formulas come in this chapter, integration by parts. Today I solved from the very well-known popular book on mathematics of class 12 written by S and they. I'll solve some problems. Let's see. First, I take this problem from short answer type questions. Integration x square sin x dx. Take this as first function u and this as second function v. Okay. So x square integration sin x dx minus integration ddx of x square into integration sin x dx whole dx. Okay, equals to, what is integration sin x? This is minus cos x, minus x square cos x minus 1 minus sin will come, minus 1 plus is 2x to integration x cos x dx. At last you put the constant of integration. Until all the integrations are over, don't put any constant of integration. Minus x square cos x plus 2. Again, you have to use this formula, integration by parts formula. Integration x integration cos x dx minus integration ddx of x integration cos x dx whole dx, okay, equals to minus x square cos x plus 2. Integration of cos x is sin x, you know very well, is sin x and minus integration, this is 1, the dx of x is sin x integration sin x dx. Okay, it is to minus x square cos x plus 2x sin x minus, once again minus of cos x will come from integration sin x, is plus 2 cos x. See, all the integrals are over. Now we can put the constant of integration as c here. This is the answer. So this is a problem I took from short answer type questions from S in the book. Okay. So this is the problem. Now I take another problem from integration by parts chapter. Problem number 10, subpart 1, integration log of x plus root over of x square minus a square dx. See, I discussed on different types of integrals where we need to apply integration by parts. See, this is a logarithmic function and before integration by parts, there was no rule to integrate any logarithmic function. So this is a single function, log of x plus root over of x square minus s square. So you need to take this whole function as first function, because we know in the rule of integration by parts we need not to integrate the first function at first hand. So obviously this is our first choice of taking the first function, so we must take log of x plus root over x square minus s square as first function. And where is the second function? Oh, there is no second function. Okay, we can take 1 as second function. Okay, I am removing this part of the first problem. Hope you noted it well. So you take this as first function u, and imagine 1 is multiplied with this, and take that part as second function v, log of x plus root over of x square minus s square into integration dx 1 dx minus integration ddx of log of x plus root over of x square minus s square into integration dx whole dx. See. Now what to do? This is log of x plus root over of x square minus s square. Integration dx is x. Just write x here, because if you write x here, it may be taken as a log of x into x plus root over of x square minus s square. Okay, so don't write x here, instead write x here, minus ddx of this. This is 1 by x plus root over of x square minus s square into 1 plus 2x by 2 x square minus s square into x whole dx. So this whole thing is a derivative of log of x plus root over x square minus s square, which is a function of a function of a function. X into plus root over x square minus s square minus, see, these two are cancelled out from numerator and denominator, and if you calculate you will get the same thing here. So these two things will be cancelled out. So after all calculations you will get this thing, x here by root over x square minus s square dx. For this part, take root over x square minus s square in the denominator as some new variable z. For the second part, x dx by root over of x square minus s square, let us put root over of x square minus s square as a new variable u, or x square minus s square equals to u square. Take differentials of both sides, you will get x dx equals to u du. So this is a very simple task of substitution. X dx is u du by u. There is integration du, which is u. That means root over of x square minus s square. So just this. So just put these things here. If you name this integral as I, so what will be the result? The result is, therefore, I will be x log of x plus root over of x square minus s square minus this. This is minus root over of x square minus s square. Okay. Plus thing, constant of integration. So all integrals are over here, and I told you after ending of all integrals, you put constant of integration. Okay, this is the problem number 10. I have taken from the short answer type part, that is under marks 4, under category 4 marks. Okay. Next, I take another problem number 17 from the book. Hope you noted it well. I am removing this part of the problem. Problem number 17 from short answer type questions under category 4 marks. What is the problem? Integration x sine inverse x over root over of 1 minus x square dx. This is the problem. NCERT, this marked the book as NCERT model problem. This is the NCERT model problem. Sometimes before using integration by parts rule, you may have to apply some substitutions to get the problem in smaller size. Okay. See what can we do with this problem. Okay, first let us substitute x equals to sine theta. Here x is the old variable and theta is the new variable. Okay, then take differentials, dx equals to cos theta d theta. Take this as I. So I becomes now sine inverse x. From these, sine inverse x will be theta. Theta x is sine theta and root over of 1 minus sine square theta. Okay, dx is cos theta d theta. So after all these calculations, see, this is cos theta will be cancelled out. Theta sine theta d theta. This is the problem now. So simple, very simple. Take theta as first function, this as u and this as v. Okay. So theta integration sine theta d theta minus integration d d theta of theta integration sine theta d theta whole d theta, and this is minus theta cos theta minus 1 minus sine will come from this integral. So these two minus resulted in plus here. So 1 cos theta d theta equals to minus theta cos theta. This is plus sine theta. At the end, don't forget to bring back the original variable, which is x. Yeah. So what is theta? Theta is sine inverse of x equals to, and what is cos theta? Cos theta is root over of 1 minus x square. So root over of 1 minus x square into theta means sine inverse of x. Sine inverse of x. Okay. And sine theta is x. So this is all for this integral. Okay. So this is our third problem in today's class. Next, I take another very interesting problem from the same book under problem number 17 in the 4 marks category, short answer type questions from in the book. So okay, take problem number 19. What is the problem? Very popular problem. This is a very popular one. Integration x dx by 1 plus cos 2x. This is the problem. And you know very well, there is a formula in trigonometry, 1 plus cos 2x is 2 cos square x. So just put that formula here, x dx by 2 cos square x. So half integration x sec square x dx. Now take this as first function and this as second function v. Okay? And half x integration sec square x dx minus integration dx of x integration sec square x dx or dx is half okay. Integration, what is integration sec square x? Integration of sec square is tan x. X tan x minus integration, this is 1, this is tan x dx. Okay. Don't put, I repeat, don't put any constant of integration until all integrals are over. Okay. So half x tan x minus, what is integration of tan x? This is log mod sec x. See, all the integrals are over. Now we can put constant of integration c here. Okay. Next, I will take another problem, which is 25 in the group problem under 4 marks category problem in short answer type questions. What is 25? Integration sin inverse x whole square dx. This is the problem. See, I told you in my lecture 7, in which I introduced integration by parts, that some functions like sin inverse x, any inverse circular functions or logarithmic functions or etc., some functions are there which we could not integrate in our previous chapters, like integration by method of substitution. So integration by parts method brought to us an opportunity to solve this kind of functions. See, this is also a trigonometric inverse circular function, and not only that, one whole square is there. So let's see, we have to take this as first function. So sin inverse x whole square integration dx minus integration ddx of sin inverse x whole square into integration dx whole dx. Okay, whole dx. So here I took sin inverse x whole square as first function and one as second function. Okay. Okay, so here sin inverse x whole square, integration dx is x, put x here in the first place, minus integration. What is the derivative of sin inverse x whole square? It is the differentiation of function of a function. 2 sin inverse x, 2 sin inverse x into derivative of sin inverse x, which is 1 by root over of 1 minus x square into x whole dx. Okay, and x sin inverse x whole square minus 2 integration x sin inverse x by root over of 1 minus x square dx. Now see, in problem number 17, we integrate this function. This is the same integral we have already encountered in problem number 17, which was a integration x sin inverse x by root over 1 minus x square. So for the second part, here I repeat for the second part, x sin inverse x by root over of 1 minus x square, put x as sin theta. That means theta will be sin inverse of x, and dx is cos theta d theta. Okay, so x, that is sin theta, and sin inverse x is theta. Theta sin theta by root over of 1 minus sin square theta, 1 minus sin square theta, and dx is cos theta d theta. See, root over of 1 minus sin square theta, it is cos theta, and this cos theta will be cancelled out with this cos theta in the numerator. So ultimately these things will remain theta sin theta d theta. This is theta integration sin theta d theta minus integration d d theta of theta into integration sin theta d theta whole d theta. Okay, so this is minus theta cos theta minus minus plus integration cos theta d theta. So I'm writing the first line here. It is minus theta cos theta minus theta cos theta, and integration cos theta is sin theta equals to, what is theta? Theta is sin inverse x, and cos theta is root over of cos theta is nothing but root over of 1 minus sin square theta. It is root over of 1 minus x square. So minus root over of 1 minus x square, and theta is sin inverse x plus sin theta is x. So just put all this whole thing into this line here. Therefore, the given integral will be x sin inverse x whole square minus twice of this thing, twice of this integral, and this integral is, the result of this integral is here. So minus twice of minus of root over of 1 minus x square plus x, and all integrals are over. So we have to write at the end constant of integration. So this is the result. Come here. So x sin inverse x whole square plus 2 x root over of 1 minus x square minus 2x plus c, and this is the end of the integral. Okay, in my next class I will do more problems using integration by parts. Okay, hope you understand all these problems well, and you need to practice. You need to practice some more problems on it. Okay. In our next class, I will take some. Bigger problems using method of integration by parts. Okay. Thank you.